This is Seth Byers, section 021, and this is our mechatronics final. On my mechatronics final, I have my LCD set up, which is a lot of digital inputs. Let me just turn this around, and you can see, like right here, there are 6 digital inputs just for this board, but actually one of these, I believe, nope, none of these. There are 6 digital inputs that go into the LCD, and there's one that comes out and goes into this potentiometer. And this potentiometer right here controls the contrast. Get it to a spot where it's good, right there. That controls the contrast. One second. And then there's another potentiometer right back here. And this one, as you can see on the LCD, is going to control volts, force, or otherwise known as newtons, and grams. So this is a scale using this FSR sensor and its potentiometers to display the value of this FSR sensor onto this LCD. And then how the code is done for that is first I have to set up all my variables. I have 4 float variables because all of these go into decimal places. My volts, my forces, and my grams, which makes this scale a little bit more accurate. Then I set up my LCD begin for later so I can print. And then we just go right into it. So first I have this capital P to do the analog read for this potentiometer right here. It's going to read that and then convert it to a scale that's 1 through 5. And this exact equation is also going to be used for my volts, which is also on a scale of 1 to 5, same as a potentiometer. And what I have is if the potentiometer is greater than 3.5 volts, it is going to set the cursor into the top left corner, as you can see the press right there. Then I will display the press FSR and what exact unit I'll be using. Set the cursor down, and that is where this value is set at. After I set the cursor there, I do this volts conversion for the LCD. Since the LCD with these variables, it's not on a scale of 1 to 5 because there's a bunch of bytes inside of each variable. And so you have to convert those bytes, the range of that bytes, into a range of 1 through 5, which I have done here through trial and error. And then I print the value, and then I give it a little delay just so you can see if I press on this, it kind of just doesn't move nearly as much as if when I didn't have it. And this is volts, and I'm pressing about as hard as I can, I'd say. And I'm at 4.9, which is about right for volts on an FSR sensor, as we have seen in a different lab. But of course, my starting value down here seems to change based on the movement position of these down here, of my power and ground going into the breadboard. These are new wires I've put in, but it just kind of happens. Otherwise, you can always just reset it, and hopefully that will change it. Not for the better, though. So that's just something you just have to kind of tinker with and keep into place and try to just get down as low as you can. There you go. As low as you can down to 0. That's probably about as close as you'll get with these power and ground cables. And then next, we move on to the newtons. Now, newtons is when this potentiometer is going to be pointing directly that away. Or, within the range of 3.5 volts and 1.5 volts. And then we do all this stuff, which is done every single time. You set the cursor, say what you're going to be doing, and then set the cursor again for the value. And then for these force values, these values I actually took from a previous lab we had to do with FSR way back when. And here you can see I have my conversion loop for volts to newtons. And all I do is I just put it directly into the if loops. And all these if loops are for each single one of these if, else, if. So each one of these converts to one of those. And as you can see, I do my equation, and then I print the force, and I also delay just to give a little bit more time to just kind of get used to. There it is. Just kind of get a set value out quicker. Now you do have to hold this one at like a certain position almost. But as you can see, it's about 87, 86. You can get up to 90 sometimes newtons. And for 5 volts, it's 100 newtons. So that's a pretty close conversion right there from the volts that I pulled over to newtons. Because what I do in all of these equations is I completely recall the equation I used for the volts and in the place of where the volts variable would be to basically recalculate all of that stuff. And then we go on to grams, which is when the potentiometer for this is mostly to the left, as you can see with the grams. And it's this part is basically exactly the same as the force that was above, because 1 newton is equal to 101.97 grams, which I just rounded up to 102 because in 100 newtons, there'd only be a 3 gram difference. And the odds of you getting 100 newtons of force is very small. So as you can see, the equation is literally exactly the same for force. I took that from the force above and put it right down here, and then just multiplied it by 102. Very simple, LCD print and all that stuff. So you do get very high number of voltage, or you just get a high number for the grams. Like this would be in the thousands or something. Boop, there you go. This should be, yeah, between, pushing down hard enough, between 8,000 and 9,000, somewhere in that area, since you're multiplying the newtons by 102. And that is basically it. That's everything. Yeah. That's it.